All right, let's go over the number 2 of the chapter test 4. On here, we're supposed to find holes and all this other stuff about this rational function, a ratio of 2 polynomials. And the first thing we learned to do was to factor. Now, you may have troubles factoring, and you may want to come in and get some help with factoring. But this part's already factored out. This part, there's an x in both of them, so we take out the x, and we have x minus 4. In the denominator, we can't take anything out, so we have a 2x and an x, and we have to come up with 5. They have to subtract because it's a negative 5, and we have to subtract to get 3. Well, I'm guessing with a 2 and a 5, we're going to have probably 5 minus 3 if I do this right. If I put a 5 over here, I'm going to have 5 times 2, which is 10. I don't think I want 10. I think I'm going to need a 5 here, so that'd be 5x, and 5 times 1 would be 2x. And to come up with negative 3, I might need to do negative 5x and plus 2x. And if I multiply this out, I get 2x times x, 2x squared, plus 2x and minus 5x is minus 3x, and minus 5 times 1 is plus 5. Now, after I got it factored, I notice those are the same. So there is a hole at whatever makes 2x minus 5 equal 0. So if I add 5, I get 2x equals 5. Divide by 2, and I get x equals 5 halves, or 2 1/2. So I have a hole at 5 halves, or 2 1/2. And to find the y value of the hole, I will plug it into the similar rational function. It's similar other than the hole, and that would be x times x minus 4 over x plus 1. Now if I plug 2 1/2 into this, I get, I'll do it in decimal, 2.5 times 2.5 minus 4 is minus 1.5, divided by 2.5 plus 1 is 3.5. And I can just save time here. I'm going to pull up my calculator and type that in, and I'm going to get 2.5 times negative 1.5 divided by 3.5, and I get a ugly decimal, but if I do math, enter, enter, I get negative 15 fourteenths. And the decimal value of that, which might be more useful for graphing, it might not be, is negative 1.07-ish. Okay? Now, so I've figured out where the hole is. I'm going to go down and put that on my graph. And so I got to go to 2 1/2, negative 14 fourteenths, negative 15 fourteenths is right next to the negative 1 line. Now, we'll go up here and find out if there are any vertical asymptotes. Well, since this is a hole, it's not a vertical asymptote. The only thing left I have is this x plus 1, which would cause a vertical asymptote at x equal negative 1. And it's a line, so we need to write an equation. And I asked for the behavior at that vertical asymptote, and since it's a single factor, it's not squared, then it's going to go opposite directions on either side of the asymptote, either that way or the other way. So I'll just say they go opposite directions either side of the asymptote. Okay. And so now I'm going to put the asymptote on the graph. And that's at x equal minus 1. So I'm going to come down here and put the asymptote on here. And I'll write up here it goes on opposite sides of it. So if it takes off to positive infinity on the positive side, then it'll go to negative infinity on the negative, or vice versa. Okay, let's continue. Horizontal or oblique asymptote. And I'm going to do quite a bit with this one. So first of all, we want to look at the degrees. Is the degree of the denominator bigger than the numerator? Well, that's 2, and the numerator is 3. It is not. So it's not y equals 0. Is the degree of the two polynomials equal? Well, this one's 3 and this one's 2, so it's not y equal the ratio of the coefficients. So then we want to do long division. Now, if many of you went back to the original polynomial, which is perfectly fine, but you need to multiply this together correctly. So I'm going to do that. So I got 2x minus 5 times x squared minus 4x. And since most of you do it in this form, I'm going to do it in this form. 2x times x squared is 2x to the third. 2x times negative 4x is negative 8x squared. Negative 5 times x squared is negative 5x squared. And negative 5 times negative 4x is plus 10x. And those two can be combined, so I'm going to have 2x to the third minus 13x squared plus 10x. And I need to divide that by the denominator, which was 2x squared minus 3x minus 5. Now, if I got to divide 2x squared into 2x to the third, I think all I need to do is multiply this by an x to get 2x to the third. But I need to take the x times the rest of it, so x times negative 3x is negative 3x squared, and x times the negative 5 is negative 5x. And then I draw the line and change the signs so I can add, and these add to be 0, and these add to be negative 10x squared plus 15x. And 2x squared times negative 5 will make negative 10x squared, and negative 5 times the rest of this will make some more stuff, which we're not going to worry about because we have enough now to determine what our oblique asymptote is. It's y equals x minus 5. Now, I'm going to do this again in a simpler method here. I can find the oblique asymptote with the reduced form. So this is x squared, what we had before, x squared minus 4x, this part, divided by x plus 1. And we can do division with synthetically. If I just use, for the x plus 1, I'd use minus 1 going into 1x squared minus 4x plus 0. That's the original portion left here, the 4x squared minus 4, x squared minus 4x, and no constant. So, 1 plus 0 is 1. Negative 1 times 1 is negative 1. Add, I get negative 5. Multiply by negative 1, I get plus 5. And I get a remainder of 5, but I don't care. This is the part that tells me it's y equal 1x minus 5. Same answers we had before. So now I'm going to put that on the graph. It goes through -5 with a slope of 1. Goes through -5 with a slope of 1. Excuse me. Got to get over this cough. Okay. Now it says determine the X intercepts. Well, I can look at the original one, but I don't want to use this 2x minus 5 because that was part of the hole. So it can't be an intercept if it's a hole. But the rest of this could cause. And the way to get y be 0 for x intercepts is to get the numerator 0. And so we have an x and an x minus 4. So to get y to be 0, x could be 0. Or to get y to be 0, x could be 4. So now I have my x intercepts that I'll put on the graph. 0, 0, and 4, 0, which 0, 0 happens to be an intercept for both x and y. It's the only one that does that. So it says determine y intercepts, and of course we get that by putting 0 in for x. If you put 0 in for the x, this is 0. That's -4, but 0 times -4 is 0 over 0 plus 1, which is 1. So you got 0 divided by 1, which is 0. And we already knew that, and that's already on our graph. Now it says graph. Well, we should have enough to do it. First of all, it has to go through 4, 0, 0, 0, and go to and away from the hole. So it must do this, and it doesn't cross anywhere over here, so this must get closer and closer to the vertical asymptote, and it must head out towards this slant asymptote. Now, it also goes opposite sides, opposite direction on the different sides of the vertical asymptote. So if it goes off to positive infinity on the plus side, or the big side, then on the small side, or the negative side of the vertical asymptote, it must be coming back from negative infinity and going this way. And that's roughly where it's at. And that's close enough. It should be look similar space here as it is over here. And you could actually plug in these points into the equation and find out where this is. And you could do that on the calculator and get those values if you want to get those more closely. But this is good enough for the sketch. That was 6 points. Now with the graph, we can determine when the function is less than 0. This whole piece, the y values are all less than 0. For x, negative infinity all the way up to -1, this graph, this is where the values of y are for those x's. And all of that is less than 0. The y values are less than 0. So we have x can be from negative infinity up to -1. We can't use the vertical asymptote, so that's an open paren. From -1 to 0, the graph is positive, and this says negative, so we don't want that. But from 0 to 4, it's negative, except for at 2.5. So I'm going to do this in two pieces, from 0 to 2.5. Oop, and I can include the 0. And 2.5 to 4. Can't do 2.5, it's the whole, to 4. I can include the 4. And there's the answer for that one. And that's page 2.